from the quiz review, which are both law of cosines problems. Let's talk about actually what makes them good law of cosines problems by talking about why the law of sines doesn't work. So in number 3, we're just going to go ahead and label our angles A, B, and C, which automatically makes 16 our little a. This unknown value of x is our little b, and then our c value is 52. Let's say we wanted to use the law of cosines. Well, for the c's we only know a side, and for the a's we only know a side. So it doesn't really matter which letter we choose. Let's choose letter C. Sine big C over little c equals, and then our target is little b. So we know the right side of that equation has to use b's, sine big B over little b. Well, the problem with using law of sines is we do not know b, it's what we're looking for, but we also do not know big C. And that would have been true if we used big A either. So we have two unknowns in this equation. You cannot solve an equation with two unknowns. So no matter what letter combination you use, law of sines isn't going to be sufficient to solve this problem. So what we're going to use instead is the law of cosines. There's 3 different ways to write it out. Since we've identified little b as our target, we want to use the law of cosines that begins with a little b. What you're looking for is a good clue for what letter to lead with when it comes to those different ways of writing the law of cosines. So this is our law of cosines that solves for little b, a squared plus c squared minus 2 times a times c times cosine b. We're just going to rewrite this equation but using our known values. We do not know little b, it's what we're looking for, but we do know that a squared is 16 squared, c squared is 52 squared, and then minus 2 times a, which is 16, times c, which is 52, and then times cosine of big B, and we know that big B is 115. Okay. At this point, we can work this out little piece at a time, but honestly, anytime you're solving for the unknown side, you can type this entire expression into your calculator as one step, and there's nothing really fancy you need to do to make sure the calculator will compute this, right? This will work out okay. Over here, when we get to this next problem, we're going to talk about the best way to set it up in your calculator. But if I enter all this in and type it out, what I get is approximately 3,663.237. Now, I say approximately because I have rounded. There are more decimals that come after this. However, we're not done with this problem, and there's a way that we're going to go back and kind of fix this approximation. To get rid of b squared, we actually need to do square root. So b is the square root. And then I tell you what I'm going to do. In my calculator, I'm not going to retype this number. Instead, I'm going to press second and the negative symbol, which is the answer button. So what it's going to do is it's going to take the square root of this number, which was the last thing I typed in my calculator, but it's going to take the square root of the version that includes all the decimals that follow 237. So what we're actually going to get is an incredibly accurate answer, even though we rounded at this step. Using that answer key in our calculator is going to fix everything for us. So what we get is b is approximately 60.524. And if we look at our picture, 52 is about that length, so a little bit longer, 60. Yeah, that sounds pretty good. Smiley face. And so that's number 3. It's just a straight ahead law of cosines problem. You want to set it up by plugging in the correct numbers in the correct locations based on what's our little a, what's our little b, what's our little c. And then it's just some number crunching in the calculator. Number 4 is also a law of cosines problem. It does require a little bit more work because in this one we're looking for an angle, which always requires a little bit of extra. Once again, law of sines isn't going to be sufficient, and it should be obvious from this picture. We don't know any angles. So no matter which version, we're always going to have 2 unknown angles. There's always 2 angles in the law of sines, and since we don't know any angles, we'll always have 2 unknowns if we use the law of sines. So instead, we're going to use the law of cosines, and since our target we'll call big A, big B, big C, sorry, I forgot to label, which makes this little b, little a, little c. Okay. Since x We're calling that big A, that's our target. We know we want to begin a law of cosines with an A. So A squared would be a nice way to begin this version of the law of cosines. So A squared equals B squared plus C squared, those are our other two sides, minus 2 times our other two sides, so in this case 2 times B times C, times cosine of, and this time, whatever value you lead with in the equation is also the letter that you end with, so cosine big A. All we're going to do is rewrite this law of cosines using specific values. For example, we know that little a is 24, so 24 squared equals 32 squared plus 37 squared minus 2 times 32 times 37 times the cosine of, and then we do not know the value of A. It's what we're looking for, our big A, so we're just going to call that big A. There's a few ways to simplify this expression from here. What I'd like to do is save the amount of times we actually have to calculate numbers. So for example, instead of working out 32 squared and 37 squared, why don't we just move the entire term? So we're going to move 32 squared with subtraction. We're going to move 37 squared with subtraction. And then so on the other side, we have our 24 squared minus 32 squared minus 37 squared. And then on this right side, we still have that minus symbol. That becomes a negative 2 times 32 times 37 cosine big A. Right? You cannot forget this minus symbol. If you forget to write a negative right here, you're going to wind up with an angle that's way too big, like 140 degrees, and that's definitely not right. So I think this, let's just go ahead and multiply this out. This is just 3 numbers. We're going to rewrite the equation. We're going to multiply those numbers together. When you multiply this out, you get negative 2,368 cosine A. And our goal is to find A, so we're working backwards. When you work backwards, you do the order of operations in reverse. So that's why we actually did addition and subtraction first. Now we're going to undo multiplication with division. And then the last thing we'll undo is the cosine expression. So we're going to divide on both sides by negative 2,368. And I tell you what, we're not going to evaluate any of this. We're not going to crunch any of these numbers. We're just going to write it as one big calculation. Our cosine A value is 24 squared minus 32 squared minus 37 squared over negative 2,368. Our goal is to find A, so the last thing we have to get rid of is cosine. And how you get rid of cosine is by using cosine inverse on the other side of the equation. So we're going to do the cosine inverse of this big expression. All right, we're going to type it all in as one step. But we got to be careful. Anytime you have multiple terms in the numerator or the denominator, you always want to use parentheses for just that numerator. So that first parentheses is automatic. The calculator is going to do that. We're going to add a second left parentheses so that we can type in 24 squared minus 32 squared minus 37 squared. Then we're going to close that parentheses in our calculator. What we've done is said this is the entire numerator. And then we're going to use the division symbol in our calculator, divided by, and then negative 2,368. And whatever that computation gives us, that's going to be our big A. So as long as we've used parentheses responsibly to group all the numerator terms, we don't have to do a lot of number crunching. We can kind of save it all for one big step in the calculator based on setting up the equation correctly. So as long as we're in degree mode, I think we're ready to go, and we are. So I enter this in, and we get an angle of 39.887 degrees, and that's approximate. That's rounded to 3 decimal places. And if we go back and look at our picture, does this look like a 40-degree angle? Yeah, sure, maybe. There's other ways to check your work. But if you had forgotten this negative symbol, you would have gotten 140 for a value, and I think that would have pretty clearly been wrong. So that would have been a good clue to go back and see what you may have done wrong. So these are two law of cosines problems. Hopefully we understand why they're good law of cosines problems, because the law of sines is insufficient. There's too many unknowns. And then setting them up just takes practice. But once you practice, you really get used to it, because there's kind of a pattern every time to how you set up the values. Plug them in, solve, plug them in, solve, and do inverse, and you have your unknown angle and your unknown side. Thank you for watching this video. 5, 6, and 7 are covered in the next video.